Hi there, and welcome back to our discussion of the geology of the Caribbean. This is part 12. We will talk about the Dutch Leeward Islands of Aruba, Curacao, and Bonaire. This will be the last physical stop on our discussion of the Caribbean. If you think about it, we have done a clockwise traverse of the Caribbean. We started with the Greater Antilles. From there, we went to the Bahamas and the Virgin Islands, then the Lesser Antilles, Trinidad, Tobago, Margaret Island, and now we finally get to the Dutch Leeward Islands. I have to tell you that the islands of Aruba, Curacao, and Bonaire have a very distinct Dutch flavor. They remind me a lot of what I saw in Amsterdam and Haarlem uh, when I was in the Netherlands, or Holland, if you will. The islands originated via volcanic activity. On this slide, you have some views of Aruba and Curacao. It's, again, a very distinct Dutch flavor to these islands. The island of Aruba is the smallest one of the three islands, with a surface area of only 69 square miles. The highest point on the island is Mount Yamanota, with an elevation of 690 feet above sea level. Curacao is the largest of the three. It has a surface area of 171 square miles. Mount Christoffel is the high point with an elevation of 1,236 feet above sea level. Bonaire has a surface area of 111 square miles. Brandeis Hill, with an elevation of 791 feet above sea level, is the highest elevation on the island. The islands of Aruba, Curacao, and Bonaire are actually aligned along the crest of a 125-mile long segment of the east-west trending Leeward Antilles Ridge within the Caribbean and South America plate boundary area. The region is actually undergoing east to west right lateral strike slip motion. Basement rocks include deformed intrusive and extrusive igneous strata, such as diorite and gabbro, as well as sedimentary rocks like radiolarian chert, limestone, and greywacke. These basement rocks were deformed in the Cretaceous period. Quartz augite diorite and quartz diorite intrude the basement rocks in Curacao and Aruba respectively. The deformed igneous rock units in these islands are unconformably overlain by Cretaceous to Eocene sediments. Compressional stresses resulted in additional folding of these rocks in the Eocene epoch. Let's talk about the core rocks that we find in Aruba. These are stratified basalts and volcanoclastics intruded by a tonalite batholith. Remember, tonalite is similar to granodiorite. The oldest rocks are Cretaceous and are found from north to south along the eastern and central portions of the island. Miocene, Pliocene, and Pleistocene reefs, eolanites, and terraces cover the western, southernmost, and southeast areas of this beautiful island of Aruba. Now, the core rocks in Curacao include lava flows, silica-rich strata, and clastic sediments such as conglomerate, sandstone, and shale. The oldest rocks are of Cretaceous age, which cover most of the southern part of the island, as well as the northwest end. A few Eocene stratigraphic units occur east of the Cretaceous area. Miocene, Pliocene, and Pleistocene terraces occur close to the coast, especially on the eastern side of the island. Core rocks in Bonaire are basaltic lava flows and pyroclastic debris, interbedded with pelagic, regular and chert, and some limestone. This sequence is overlain by turbidite conglomerates, fluvial sediments, and additional limestone. Cretaceous rocks are found in the central zone and in the northwest tip of the island. Everywhere else, Miocene, Pliocene, and Pleistocene terraces are found. Well, guess what? We have now concluded our tour of the Caribbean. I hope that you have enjoyed it and you have learned a few new things about the geology of this tropical paradise. Now, there's a part 13 to this presentation, and that addresses the references that I consulted in putting together this presentation. I suggest that if you would like to continue to explore the geology of the Caribbean area, that you look at those references. In any case, thank you and see you later. Bye-bye.